Mathematica, first we are going to start by defining scalar variables. So over here var1 is variable 1 is a scalar variable. I am defining it as a row, and in order to execute the command you have to press shift and then enter. Okay, that executes the command. Now uh, now in order to see what is it that you have created, press enter. It is going to open another code block. Okay, so this continuous line is basically a block of code. So if I say var1, it's a defined variable. So, and if I press shift enter, then I am going to see that variable 1 is row. Now, once you have defined a scalar variable, you can do lots of different operations on it. So, for example, you can do a square. In order to do a square, just press this particular power button and then say 2, and if you say enter, you will get row square. Now, in order to see, this might look trivial, so let us say I want to do 1 plus variable 1 whole square. Okay, so then it will give me 1 plus row whole square. If I say expand, anytime you are defining a function in Mathematica, you make use of square brackets. Okay, so expand is a function which expands any closed function. So 1 plus row whole square will be 1 plus 2 row plus row square. Okay, so by now you understand as to what is the significance of a symbolic language. It is that you don't have to assign values to variables. You can do things analytically. So 1 plus row whole cubed, this is the expression. Now, and so on. Okay, so you can do different things. So this is about scalars. So you can create multiple things. So let us say variable 2 is so one was density. Let us say another is temperature. Okay, temp. So I could have defined these two variables, and then I could have done something like this. Okay, so alright, so that is about definition of scalars, which is sort of trivial. Next, let us talk about vectors, definition of vectors. Now, when we are defining vectors, so there are two ways to define vectors. So first is, so let us say I am talking about a position vector. Okay, so let me call it as position vector. Now, position vector will be defined by x1, x2, x3 coordinates. Okay, now there are two ways to define this. So first is, you can go ahead and define it directly. To define a vector, you are going to use these brackets. Okay, and I can write it as x1, x2, x3. Okay, so this is the manner in which I can go ahead and define a vector directly. It need not be 3 cross, it need not be 1 cross 3, it can be 1 cross 4, 1 cross 5, any size. Okay, so for example, now if I press shift and then enter, then this has been executed. Once a variable is defined, it is shown in a different color. Before it is defined, it is shown in blue, and after it is defined, it is shown in black. Okay, and okay, so now if I want to say, for example, what is position vector, okay,
Sir,
then I can see that it's x1, x2, x3. Yeah.
is that row vector or column vector?
This one is a row vector. Okay, so if you are in any doubt, you can write like this: matrix form. So matrix form is a function. So again, matrix forms, square bracket open, the variable name, square bracket close, shift enter. So now you can, sorry, that was a column vector, my mistake. Okay, so this is a column vector. All right, now if I is a column vector. All right. Now, what are the other ways of doing things? Other ways of doing things is, so this was one way. Second way in which you can do things is, so let us say I want to define a velocity vector. Okay. So what I can do is I can first define something called a unit vector. It is a function available in Mathematica. I can specify its size. So let us say I want to do 3 cross 1, a column vector. Okay. And then what I will do is I will multiply this with 0. Now one of the things about Mathematica is whenever you want to look at product between two is product between a scalar and either a vector, a tensor or anything, you don't have to put star into mark or anything. If you put space in between two quantities, then automatically that's a product operation. And please remember that so if I have a vector a, let us say a1 a2 a3, if I am multiplying it with a scalar, let us say 2, then what will be the resultant vector?
0, 0, 0.
Not here. I said some vector a1 a2 a3 multiplied by a scalar 2. What will be the resultant? What will be the resultant vector if I multiply it with
vectors.
Huh?
A constant into that vectors.
Arey Baba. What will be the entries of the vector? It will be 2a1, 2a2, 2a3. Whenever you are multiplying a vector or a matrix with a scalar, you are multiplying all entries of the vector or the matrix with that scalar. So if I multiply 0 with a unit vector, then what would I get? I would get, so if I do not put a semicolon, then whatever is the output of this statement, it is going to show up. So if I just press shift enter, then you see I ended up with a 0 vector, 0 0 0. Okay, so this is something I can do to initialize my velocity vector. Okay, so this is something I can do to initialize my velocity vector. Now once I have initialized, I can assign any value to any entry. So for example, now if I want to define velocity vector as v1, v2, v3, I can say velocity vector of the first row would be v1, velocity vector of the second row would be v2, velocity vector of the third row would be v3. Okay, now if I go ahead and say matrix form of velocity vector, what will I get? I will get this. I will get v1, v2, v3. Okay, so these are the two different ways in which you can define your vectors. Either you can go ahead and define the vector directly like this, okay, or you can either go ahead and define your vectors like this, or you can define a 0 vector initially of whatever size you want, and then you can define the non-zero entries explicitly in this particular manner. Okay, all right, so just to fine, so this is this. Now in the same manner you can go ahead and define matrices too. So first we started with a scalar, then a vector, then a matrix. So let us say I am looking at stress. Okay, so for stress I could do like this, like S11, S12, S13, comma S21, S22, S23, comma S31, S32, S33. Okay, So what is it? So each one of them is basically a row. Okay, so now I have a matrix. So if so this is the stress this is how you define a sorry so this is how you define a matrix. Okay, so each of these is the row. Now I could go ahead and say matrix form of stress, and then I'm going to get this. Okay, so as you can see, first row, and so on. Okay, so this is how you define the matrices. Is it clear until here? Definition of scalar, vector and tensor. And now if you want to, let us say, change one of the entries. So let us say you want to take S33 and put it as 0. So then you say S33 of 3 comma 3. Okay, so whenever you are talking about index of a matrix, you have to use two square brackets. Okay, two square brackets, two of left type, then the index, and then again two square brackets to close it. So if I say S33 equals to 0, okay, and then I look at this matrix. Okay, so now S33 has become 0. Okay, so this is how you define your scalar, vector and matrix. Now after this, what is the next thing you would be interested in when it comes to these vectors and matrices? Next thing would be some sort of a scalar vector multiplication. Okay, so let me just take this one only. Okay, so now let us say I am interested in doing a dot product between a okay, first let us look at the dot product between a vector and a vector. Okay, so what dot product is achieved by simply looking at a dot. Okay, so if I say velocity vector dotted with position vector. Okay, so I can do a dot product between two vectors in this particular manner. And then what will my dot product be? My dot product is going to be v1 x1 plus v2 x2 plus v3 x3. Okay, so this is how you do a dot product between vector and a vector. Now if I want to get, let's say, magnitude of the velocity vector, then what should I do? If I want to get magnitude of velocity vector, then what do I do? Anyone? Is anyone
Dot product with itself.
That will give me the magnitude? Are you missing something?
No, sir, square root.
Square root of that. Okay, so I have to say sqrt square bracket open square bracket closed velocity vector dotted with velocity vector. If I do this, then I am going to get, if I do this, then I am going to get the square root of the velocity vector. Okay, I can, okay, next let us say I am interested in the dot product between a matrix and a vector. So let us say I want to do stress dotted with position vector. Okay, so again it's a simple dot. If you want to look at matrix form so that it is clearly visible as to what is happening. So when you do a dot product, what are you supposed to get? First row multiplied by the column. So S11 times x1, S12 times x2 plus S13 times x3, first row. Second row, S21 times x1 plus S22 times x2 plus S23 times x3 and so on. Okay, so this is how you do the dot product between a matrix and a vector. If you want to do dot product between matrix and matrix, so this is what it is going to be. Okay. Okay. And then once you have it in the matrix form, you can do any sort of an operation you want. So for example, let us say you want to look at transpose. Okay, so transpose is an operation, right? You can do on a matrix. So you say transpose of stress, and so let us say matrix form, because again you can't see it clearly what is happening. So I'll say matrix form of this. Again, increase the size so that you can see. Okay, so it got transformed. Or let us say you are interested in the determinant. So you say det. Okay, so if you say that, then you are going to get the determinant. Okay, so or let us say you are interested in the inverse. Okay, so again I will say matrix form of inverse of stress. Okay, it's a little bit nasty, the inverse thing, so let me not use the matrix form here. Right, so yeah, so the inverse, the expressions are a little bit big. Okay, so fine, so you can carry out any. So now you know how to define scalar, vector, matrices. You know how to carry out some either multiplication or any, how to apply any other operator on this particular set of quantities. Okay, any doubts up till now on the definition of these different things? Okay, I'll pause my video here.